So this is the 2018 Chemistry Year 11 Triple Award paper. So the first question asks you to identify the three raw materials that enter the blast furnace. So A, iron ore, coke and limestone. Okay, the other raw material of the blast furnace is hot air, but that does not enter at the top. Product B is slag, because it always comes up on top, and product C is iron. Underline the element which is removed from iron oxide during the reaction, that's oxygen. Put these in correct order. So F, add excess copper oxide to dilute hydrochloric acid. D, filter to remove excess copper oxide. E, leave copper chloride solution to evaporate at room temperature. First off then, that's actually the second question, but we'll do it first anyway. By drawing arrows in the diagram, show the direction in which circle ions move during the process. So chlorine will go to the positive because it's negative. Copper will go to the negative because it's positive. Using these keywords then, the breakdown of copper chloride solution using electrical current is called electrolysis. Electrical current enters and leaves the copper chloride solution by electrodes. Then it says put a tick next to what that E- represents, that's electrons. The solution will turn paler as the copper ions are removed, and what will be formed will be chlorine. Identify ethane, so ethane is C2H6, would be A, it's got 2 carbons, 6 hydrogens. Propene then, C6H6, would be C. This is quite nice because they've set it up for you the first one, so then all you have to do is remove the double bond and straighten them out to draw the other one, and then name that. It would be chloroethene. Okay, it's ethene but it's got 1 chlorine. Nice question here then, working out the MR. So 1 carbon, 4 hydrogens, 1 oxygen, added all together would be 32. Then using the value for temperature change for methanol, you do 100, which is the mass of the water, times by 4.2 times by 25, which would give you that value. Okay. Give the letter correct to the conclusion of the student investigation. The greater number of carbon atoms in an alcohol molecule, the more energy is given out. Give the letter to the structural formula of methanol. That doesn't look right. That doesn't look right. That nearly looks right, but it isn't. Okay, it's that one because the O is always attached to the carbon. Hexane has a boiling point of 68. Give the name of the fraction it contains to, so it's going to be petrol. Okay, because the boiling point there would fit into that one. Okay. 1 alcohol is found in kerosene and in diesel. Give the number of carbon atoms. So look at kerosene, look at diesel. The overlapping carbon atoms will be 14. Give the number of carbon atoms in the alkene, which is the lowest boiling point, and that's going to be C1. Moving on then, name the fractions where the demand is greater than the supply. You're looking for ones where the lighter grey column is higher up than the dark grey column, so that's going to be petrol and diesel used in cars and buses. State 1 environmental problem related to disposal of all types of carry bags. Releases toxins when burnt. Calculate the percentage of plastic bags sold in 2013 which was single use. So first off you have to work out the total number of plastic bags sold in 2013 divided by the single use ones, and then times that answer by 100. Okay, which will give you 95. Looking at information then about plastic bags. So the bags were made from the same thickness but from less dense plastic, that was true. Consumers reused their plastic bags more often, that was also true. These 3 then were not true. Nice question then, showing the ionic transfer of electrons from sodium to oxygen. They gave you the charges on sodium, asked you to work out what would be going on oxygen, so it would be 2,8 now, not 2,6, and it'd be -2 because it's gained 2. Okay, balance symbol equation between the reaction of sodium and oxygen. You make sodium oxide. Okay, 2 sodiums, 1 oxygen, balance it out because you want to get that to be 4, so 2 times 4 would be 4. Give the diagram which shows the bonding in hydrogen and chlorine. Okay, chlorine's got 7, hydrogen's got 1. It's covalent, so it's not going to be that one. Chlorine's got 7, so it's not going to be that one. Hydrogen's got 1, so it's not going to be that one, so it has to be C. So here is information then about 3 different molecules. They are all giant covalent molecules. Using these words then, discuss why diamond is used in drill bits. it's hard and it doesn't conduct electricity. Graphite, again, using pencils because it's hard. Fullerene, using drug delivery because it's hollow, so you can put the drugs inside for people to swallow. This was actually a really easy 6-marker. You had to explain the 3 methods of firefighting and put different parts of the fire triangle. So create a fire break by cutting down trees, removes the fuel. Pour water over it, removes the heat. Pump in CO2, removes the oxygen. Then quite a nicely set out exothermic endothermic question. Calculate total energy to break all the bonds in the hydrogen and nitrogen molecules. So you had 3 hydrogens, 1 nitrogen, add them together, gave you 2, 2, 5, 3. Then the total energy to release all the bonds in ammonia, 1, 2, 3, 1, 2, 3. 6 times by 391 would give you that number. Reactants minus products gave you minus 93. Minus 93 would make it exothermic, so it's going to be that one. State what happens to the yield of ammonia as the temperature increases. So yield of ammonia decreases as the temperature increases. Underline the approximate percentage yield of ammonia formed under these conditions. 200 atmospheres of pressures by here. 450 is going to be between here and here. The closest one to 450 is that one. So I've actually made a mistake there. It's going to be that one because it's going to be between them 2 numbers. It's not going to be that number. Okay, sorry about that. Complete the word equation. You've got nitrate, so the acid's going to be nitric acid. Litmus paper turns from red to blue in a test. State the properties of the gas which cause this to change. It's alkali. They're alkalis. The gas formed is ammonia. Nitrous fertilizers pollute streams and rivers. State how nitrous fertilizers get into waterways. It rains and water runs into the streams. Blank page, you don't need to do anything here. Then a nice balanced symbol equation. Hydrochloric acid, you gave you the symbol for it. Sodium hydroxide, if you needed to, you could go to the table of ions. They're both negative, positive 1. Again, sodium chloride, if you needed to, you could have gone to the table of ions and then water. Down the bottom then here, some volumes of hydrochloric acid that you need to calculate the mean of because you're going to use it on the next page. So state the apparatus X, that's a pipette. Indicator shows the point of neutralization. Then it asks you to calculate the mean, which I just discussed on the previous page. The experiment was repeated using sketch a graph to show the axis below shows temperature changes as more acid added to a total of 30. So it's going to reach peak around 15 because it's half of 30. And sorry, it's going to be that one. And then this is the one that's added when you use half the concentration below. Give a reason why iron formed this reaction is molten. High temperatures causes it to melt. Displacement, aluminium is more reactive. It's going to steal the oxygen. So that's going to be the symbol. And then you've got 2 ions on this side. So you need 2 ions on this side. State which substance oxidifies. Give a reason. Aluminium gains oxygen. A mixture of magnesium oxide and aluminium powder is heated. There's no reaction. As soon as you see that, you know magnesium's the most reactive. Okay, you know aluminium's more reactive than iron because it displaces, so magnesium's the top, then aluminium, then iron. Which best describes what's going on? What are the positions of the 4 metals in the reactivity series? This then is a lot of thinking for 1 mark. Okay, the first thing I did here is that we know that copper is not very reactive. Okay, so the fact that there's a ticks all along here, going on here, copper cannot replace copper sulfate from itself, so it's not going to be that one. Okay, it's not going to be this one because copper cannot displace tin, iron and zinc, so that one's wrong. Okay, this one was a little bit weird then, but down here you're not seeing the reaction that you need to see with zinc and with iron, so it's not that one, so it's B. Give an example of a test that's not needed. I've already explained this, like stuff like copper reacting with copper sulfate. They're the same element, so will not displace. It's not needed. One change you will see during a displacement reaction, the blue solution will turn green, okay, and you'll start to see silver deposits form. Balanced symbol equation then. You've got copper plus silver nitrate. They've given you the chemical equation for that. Makes copper nitrate plus silver, okay. Copper's 2 plus, nitrate's 1 minus, so balancing it out.